Welcome to the Ash Cloud. I'm Ash Sweeting. The complexity of biology is what has enabled millions and millions of organisms to evolve to what is life on Earth today, all the different ecosystems and natural systems that exist. What we've learnt about biology and that complexity is also providing opportunities to solve some of humanity's greatest challenges. Today I'm joined by Tom Williams from Number 8 Bio, who is leveraging this biological complexity to both improve livestock productivity and decrease the climate impact of animal production. Tom, thank you very much for joining me today.
Great to be here, Ash.
So you studied synthetic biology, PhD, Macquarie University in Australia, and how did that get you into addressing a livestock methane and starting a company in that space and getting to where you are now with Number 8 Bio?
Yeah, I grew up in New Zealand, in the Waikato, big dairy farming region, and enteric methane was in the news even when I was a little kid. Um, and it was in the back of my mind for a long time. So, I had what I now consider a detour into synthetic biology. I did a PhD at the University of Queensland and then became a senior lecturer at Macquarie University with a large research group, mainly working on engineering yeast genomes and yeast metabolism to make sustainable goods, but also to like fundamentally understand how life works. In essence, though, that is harnessing the power of biology and microorganisms and understanding biological complexity. So I think I've always been driven by the potential for impact. Um, I suppose I got to a place where I'd been through a couple of cycles of academia with grants and publications and students, and I wanted a bit more fun and a bit more impact than I was having. And as I'd become an expert in microbiology, realized that in my mind at least, the most impactful place I could put that knowledge is enteric methane, because you've got a really potent greenhouse gas that's also wasted nutrition from feed. So there's not too many examples where you've got a climate value proposition connected to a productivity incentive for adoption, and where, my particular skills dealing with extraordinary levels of biological complexity would actually be relevant and useful. So that's what drove me into this space.
I love biological complexity because it's both the the nuance, it's the opportunity, but it's also because that complexity enables biology to be all the amazing different diverse things it is,
Yep.
but it is also just there's so much to it and there's so little that we actually know. So, actually understanding enough of it to move in the direction we actually want it to go
hmm
is the huge challenge. So I guess where do you start? Where did that start? So you make the decision, I'm going to run in this direction, but what happens next?
Yeah, we had an interesting journey. Being a synthetic biologist, I thought most of the solutions to the world's problems lied in engineering yeast to do something new. And that's it sounds stupid when you say it now, but that's how we started Number 8 Bio. We were engineering yeast to make bromoform and other seaweed molecules and bioactives, which we got that to work actually pretty quickly, as good as it ever could work, but realized that it was likely still too expensive for the feed additive market with enteric methane. And also, bromoform itself, there was some hesitancy around that in some markets as well. So knowing that it costs too much and that there's nothing we could do about that, we completely pivoted. And the way we did that was using an in-house in vitro rumen screening system where you take stomach fluid from a cow into the lab and dose it with different versions of products and check how much methane it makes and how much nutrition it makes. So we made that a bit smaller and a bit more automated than normal, and we do about 100 of those per week still to this day. And over the years, have done many, many thousands of different potential products in the enteric methane space. So, that we started the company as a bromoform yeast play and then pivoted to we will screen the entire solution space. We'll look at peptides, enzymes, probiotics, natural extracts, small molecules, combinations of all these things, different concentrations of all of these things to find a winner. And then we took that same philosophy through live animal studies. So I guess our story is that we we acknowledge reality quite quickly, and to deal with the complexity of the space, we do a lot of screening. We know that human knowledge of biology is incomplete, and the best way to succeed is to have as many shots on goal as you can. So that's what we've done. We now focus on a single molecule, which is an organic chemical, giving good methane decreases and good productivity improvements.
And just in terms of the process, so you're based in Sydney in a very urban area. There's
Yep.
not many cows around. How do you go about kind of building the team, the partnerships, the funding pipeline, all those because all this research isn't cheap. And also when you're pivoting, you need to have the confidence of your investors that okay, they have the confidence in you to make those right decisions. So how did you navigate that space?
That's yeah, good question. I think we're fortunate to have the support of the investors that we do have on the cap table. The main investor is Main Sequence Ventures, and we're very aligned in that we're trying to solve a problem here, no matter what the technology is. And there's no point kind of rabbit holing on the wrong technology if it's not going to lead to a solution that compels customers. So, we've always been I guess very forthcoming with issues along the way, and it's worked incredibly well. Like the investors and the team have been along for the ride with whatever challenges and pivots have come our way. I think it's just about alignment and vision and transparency.
And the partnership side of things, how is that working?
Like with potential customers, do you mean?
Or in terms of where you're doing the research, are you using
Oh,
CROs?
right.
Are you using commercial farms? Are you
Yeah,
um,
yeah.
are you focusing in New Zealand, Australia, more
Yep,
broadly?
yep. Well, the shotgun approach that we take, which we're not taking anymore, in terms of finding a molecule, but we are in terms of formulations and, different species and different breeds and feeds and all that sort of thing. Yeah, because we cast such a wide net, we do have to trial with virtually everyone that exists in this ecosystem in Australia at least, and we have been doing that. So yeah, we work with the main universities, we work with contract research groups like EpiVets who have been wonderful for us. And we're starting to branch into other jurisdictions and look at how we do research there as well, in particular New Zealand.
And what's back to there's a matrix also in terms of finding the right product because one, you need to find something that works. Two,
Hmm.
you need to find something that will meet any regulatory process.
Hmm.
Three, it needs to work in the environments that cattle are raised in and need to be able to give to animals that are maybe up in remote extensive grazing or in dairies. Um, and then there's the manufacturability of it. You might have something great, but if it's really, really difficult, and then there's a cost of manufacturing it as well.
Yep.
So how do you untangle all that or build that out into something that you can, take to the market?
So,
That's where you're at the
in
moment, and that's the current
yeah,
challenge.
in a space like this where we are up against extraordinary biological complexity, although we take many shots on goal, ultimately we do have to pick something, right? And focus on it and build that out as a product. And what that means is that whatever the nuances or the quirks of that product happen to be after you've chosen it, you just kind of have to roll with the punches. So what that means is that we follow the science in many ways with the product. So we do all these tests and we observe very precisely what's happening and follow where the science tells us to go. So an example of that is that we were initially exploring the use of our additive in high grain diets on feedlots and found that this particular molecule, on its own at least, isn't suitable for that diet. We had hydrogen buildup issues and dry matter intake reductions and all the consequences that flow from that. Whereas on pasture, those issues were never apparent. We get the exact opposite. We get productivity uplifts, all the time. So what that said is this product is more suitable to this particular market, i.e., grazing cattle and sheep, than it is to feedlot diets. So that's where we now go with our initial push because it's such a long time to solve an issue like that. We have actually now solved it. We have a feedlot product in the works. But yeah, that's an example of how we deal with things.
And the methane. is becoming a much more political topic, as well as obviously there's the climate is a very potent greenhouse gas, and much more warming contribution than CO2 and many other gases. But it is also becoming more political. And I guess, what's your experience in that space? Where do you see the headwinds? Where do you see the tailwinds? And, obviously different parts of the world are also different. So how do you manage that, I guess, from your side of things, but also from the risk perspective side of things?
Yeah, we've felt that there is enthusiasm for emissions reductions in supply chains and from governments and from very large companies, but that it's quite a slow moving space at the moment. That I don't think it's a thing that would carry our near-term success at the very least. So we've really been laser focused on providing a intrinsic value proposition to producers so that the monetization of emissions reduction will be a cherry on top for them, and that they'll primarily be motivated by not losing 10% of their feed to the atmosphere, if that makes sense.
That makes a lot of sense. And what do you think the potential is in to actually, use your approach? Because I guess to take a step back from this, you've got, you said there's one molecules, but you've got one molecule, but when you start looking at that rumen and the complexity of that rumen, there's literally billions of different
Hmm.
microorganisms in there.
Hmm.
And it's not like they're nice little students sitting in a classroom all doing what the
Yeah.
teacher tells them to do. They're competing, they're collaborating,
Yep.
and that's just over all the different metabolites, not just over one. So it's a very complex environment, and to think that, obviously you need to take steps forward and one molecule will do a whole lot of different things, but to think that in 20 years time we're still limited to a single molecule approach, um I think that's naive. Where do you see that? What's your vision for where you see things, in that medium to longer term?
Yeah, I agree with that. I don't think we have a silver bullet, and I don't think our competitors do either yet. And we've got this wonderful discovery platform that I mentioned at the start. We screened around 5,000 different products in the lab, and we've built on that actually with a more nuanced bioreactor system that can actually predict the outcomes of live animal studies in terms of productivity. So we're really well set to find additional molecules for different markets and molecules that can be stacked on top of the first one that we have. Um, and I think that's where the future lies. There's not going to be like a single molecule takes all in these markets. And it doesn't have to be for there to be venture scale outcomes and successes. Like it is, enteric methane is quite a large and diverse market. That said, though, you've got to balance, I guess that need for different molecules with the realities of regulatory agendas. You've got to do quite a bit of work to get something registered with the European Food Safety Authority or the Food and Drug Administration, and I don't think it's realistic to do that with like two novel molecules at the same time. So, we've got to go pretty hard on product one and get success from that, and then that buys ourselves the right, I suppose, to continue innovating and build on top of it over time.
And all the, everything you've mentioned, they're not cheap trials to run.
Hmm.
So back to the, and the building the next generation of artificial rumen that you mentioned. Um, and I think, globally, venture finances, unless you're in AI and there's the billions and billions being thrown into that, a lot of the areas where there was more venture finance, it's getting tighter.
Hmm.
And especially in the ag tech space, it's getting much tighter. And then on top of that, especially in the animal ag tech space, it is even tighter. So, how do you see that challenge? And if you have managed to navigate that more successfully than many others, what's the secret to, well, what can you share of the secrets to your success?
Yeah, it's a really tough fundraising environment in enteric methane because we're this mishmash of climate tech, ag tech, and animal health company. right? So we're in a highly regulated space, except for Australia, um, and we're not AI, right? So normally, when you're in a highly regulated space, you have to wait a long time before you can get revenue and have revenue support your capital raising. And generally, that's okay. If you're a human drug, there's a very like well-trodden path for that, right? You can raise $100 million if you've got a successful human drug in the pipeline because everyone knows that the market size is enormous and you'll have it cornered. You'll have yeah, very strong patents around that, for example. Whereas it's a bit different in enteric methane because the market size is not as big as a blockbuster cancer drug or, whatever it happens to be. So we typically can't tap into those types of investors that are familiar with the highly regulated biotech path. However, as you mentioned, most other traditional venture capitalists might be into ag tech or climate tech, and both of those are not seen as particularly like lucrative compared to AI at the moment. So that's hard as well. So, like our strategy is to align with investors that can see the big vision and the end point, but also to make ourselves as resilient as possible with commercial traction, whether that be actual revenue or offtake agreements, because then that opens you up to a whole diversity of normal growth stage investors, let's say, that'll just look at the numbers and say yes. So that makes life easier if we can get to that level over the next couple of years. And companies like us that can't do that may struggle to raise just off of the climate angle.
Given the importance of livestock globally, over 1.5 billion people across the world rely on livestock for their livelihood. Many, many, many more rely on livestock for nutrition and protein and those sorts of things. And um, it's fairly well established that, reducing livestock emissions is a significant opportunity to limit warming and have an actual impact.
Yep.
And given that opportunity and the amount of airtime and media time that the conversation gets and the hugely disproportionate amount of funding that it gets, where do you see, or is there anything you think that governments should do or policymakers should do to better align those opportunities with the capital to actually realize them?
Yeah, for sure. I think obvious things that governments can do are to make regulations safe but fast, if that makes sense. Like we don't want cowboy approaches with dangerous things entering the market, but it is extreme the amount of work needed to do to get a product like this registered, and it doesn't particularly align with the timelines needed for the climate and for agricultural productivity to provide protein to everyone. So they can do that. They can make lighter regulations, I suppose, and the other is incentives wherever they can. I'm not a huge fan of sticks, but I definitely like the idea of carrots for producers and supply chains that are willing to reduce their emissions and partake in that type of activity.
Are you actively speaking to anyone in that policy space, or you're more head down and get on with it and let others take that role?
Yeah, we are engaged with regulators and government, but we're also, you know, on that spectrum, we're definitely more towards the ends of heads down, and make something that farmers love.
And what about the balance between the opportunities? So when you start looking at livestock and livestock emissions, you've got the fact that 70 or plus percent come from the global south or the lower middle income countries. And they're also the ones with I guess, the greatest, food security and productivity and human security implications as well. So is that part of your focus as well, trying to get products that will work in the global south as well as obviously the Australian and other markets you've mentioned?
Um, at the moment, it's not our focus. Yeah, we just really have to be laser focused on our home market in Australia, and then after that, where most of the cattle are, with the largest herd sizes and the most professional farming practices, because that's just the realities of how to scale revenue. I'm interested in your thoughts on how to solve that particular issue with, the large number of ruminants in parts of the world that that don't align with that strategy that I just mentioned. But in my mind, that is probably another place where governments and philanthropists can step in, where the commercial strategy may not align with what a startup and its investors have to do. But yeah, what do you think about that, Ash?
I think there's Well, I'd take a step back, and I think that things that happen in one part of the world are likely to happen. Their impacts, if you even if we look at what's happening in the Middle East now, the impacts of things can very much trickle over or spill
Mm,
over more than a trickle and impact, pretty much everyone on the planet. And the opportunity to if things go badly in the global south, depending on where it is, this is a slightly generic statement, they can likely spill over into the developed world in terms of increased
hmm
migration, increased conflict, as well as the fact that the warming impacts will get to the northern latitudes and southern latitudes as well. Um, and I think it's not easy because if it was easy, some of these things would have been done a long, long time ago. But I certainly think that the value for the producers and the people on the ground and having them have a real value is is key to adoption of anything. In some ways, my favorite ag tech adoption story, it's a bit twisted, but well, not twisted, it's just peculiar. It's actually in Afghanistan, and it's the implementation of solar panels for irrigation in the southern parts of Afghanistan. And in the mid like 2012, 13, 14, there was no solar powered irrigation in in Helmand. And within 4 or 5 years, there were tens of thousands of units. And the farmers who implemented that, one, none of them ever had electricity. There was no electricity in these villages. I'd been to many of these villages when I was there, and there was no electricity. There was, in many ways, just like jumping into a time machine and going back 500 years. 95, virtually all of 95% of these farmers would have never spent a single day in school in their entire life. They were illiterate. They had to navigate getting these solar panels from Pakistan across the border there, and then through various different districts that were either governed by the insurgency, by the Taliban, or governed by the government and all the NATO soldiers and all that sort of stuff was present. So they overcome not ever using electricity, not being able to read and write, and bringing this technology through war zones to put these solar powered pumps in. They put them into fund to grow poppies. So obviously they're growing an
hmm
illegal crop as well. But the value was there for them to overcome all these obstacles.
Right.
And
And were they paying for it? Or were
yeah,
they
they were
getting
paying
it?
for it.
They
There was
they were
no,
just
no,
paying
they
for
were
it.
paying for it.
Wow,
They were
that
paying
is a
for it,
that is a very incredible story.
or the financing was either coming from them or from their opium
Uh-huh.
dealers, people they were
Uh-huh.
selling the opiums for. So it's
Yeah.
like if the incentive's there, the farmers will overcome these very significant hurdles to get some technology that they want to use.
Yeah.
Um,
Yeah, that's a super interesting story. Um, I suppose they probably had some scale already. And they had probably good margins on the poppies. But I like my mind goes to back to enteric methane. How do we roll out and I guess the global south? Look at the average herd size of dairy in India. It's like 5 or 10 animals and that type of thing, and that they're not geared towards getting 50 liters a day, right? They're not productivity minded necessarily. I do you think that's a different challenge or a harder challenge, or do you have any thoughts on how
I
to
think
approach
there's
something like
both
that?
sides of that. There's going to need to be financing to do any of this stuff in the global south because the farmers that they just don't have the pockets to do that. When you start looking at the human side of this, one of the most impactful things you can do. So I interviewed someone, a guy called Tim Pruitt, an old friend of mine from the Kabul days, in an early episode, and he was saying that more than over 50% of world's population live on less than $6 a day.
Mm,
So that's that's a coffee or two depending on where you are. For the people in the global north. Um, so the access to funding is a huge challenge in this space. But the benefits are also very real. And in terms of with many of the vulnerable families, if you can even just give them a chicken, and they can suddenly turn whatever limited food scraps they have and whatever worms and grubs and stuff the animal can pick up in their yard into an egg or
Hmm.
handful of eggs a week. One, you're drastically changing their diet in terms of putting some high quality protein in there, and then if they've got a few eggs spare that they could sell in the markets, then they've actually got some cash to go and buy other things. There was some great research done by I think it was done by ILRI, um, in Tanzania, that looked at the incidences of mastitis in dairy cows and the effects on those communities. And what they found out that was when there was high levels of mastitis, obviously farm incomes or farmer incomes went down. And the first thing they did was pull the daughters out of school. So girls'
Mm,
participation in school went down. And it's fairly well established, very well established, that the best way to have a more educated following generation is to have more educated mothers. And if you don't have the girls going to school being educated, you're not educating that next generation of girls and boys. There's also the connections between um, fertility rates in humans, how many kids a woman has, and education. So once again, if girls aren't going to school, you're impacting future population growth. So all these things are very, very intertwined between the
mm,
animal health and human health and prosperity and the whole society, which means that there's a huge opportunity to be realized globally by getting them right. The challenge is getting the funding and the right
yeah,
projects and being able to do that at the scale that has impact and within all the cultural nuances that exist in, all these different societies, to have that impact. And it's not I think it's fairly well established that the old colonial approach of someone from Europe walking in and saying, "I'm from Europe, I know more than you, I'm right and you're wrong," has been
yeah,
proven to, be redundant and not successful.
yeah. Fascinating. I wasn't aware of the connection between protein and education and fertility rates, but all makes perfect sense. If someone can
It
solve that,
keep,
it'd be a huge lift.
it keeps things interesting, that's for sure. But it comes back to if you're if you're able to make use of whatever resources those people have more efficiently and there's less waste in that. And there's a lot of low-hanging fruit in terms of, just making sure the protein and energy levels are balanced or the forage is as good a quality as possible or those sorts of things. But if you can increase efficiency that feed is turned into food or something
Yep.
useful, then the work you're doing has a huge application. But it then obviously needs to, things like cold chains and all those sorts of things, they can be challenges
Yeah.
anywhere. As soon as
Yeah.
power supplies become less reliable, they become even greater challenges. Not
Yep.
Don't know whether you need a cold chain or not. We haven't actually dug into that side of things.
No, no, we're just boluses. They're very stable, but yeah, would love to get them into Africa and other places in the future. That'd be amazing.
So on to that, so you're looking at a slow release bolus, so it can be used in a um in a grazing situation. How's that progressing? And I guess how far from market are you before you have the first product ready to go?
Yeah, we spent most of last year doing studies in fistulated cattle. For those who don't know, that's an animal with a hole into its rumen where you can put things in and take them out, and they're great for studying a bolus, which is like a large pill that sits in the room in the first stomach chamber and slowly releases an ingredient. So we spent a lot of time testing different bolus formulations and taking them out of the fistulates every week to weigh them and determine how much material had left the bolus, and determine the effect that it had on methane emissions. So, we did about 10 fistulate studies at the University of Sydney last year, just rolling constant different formulations, trying different things, trying to understand how to control it and make it work. And the early signs from that are that, we'll get a good methane reduction of, up to a couple of 100 grams per day, which is substantial. And that the bolus will last for up to 6 months. So, the initial proof of concept is there, and at the moment, we're rapidly going through product development trials in target animals, honing in on the dose or the type of bolus that gives the best productivity uplift, and then By mid-year, we're locking in a formulation and we're doing large commercial trials with a few select partners while we scale manufacturing. We can make about 50 of these per day. We need to get up to thousands by this time next year to really go to market. So there's a lot happening at Number 8 Bio at the moment.
That that's moving very fast. That's probably moving faster than, when you start looking at, new products, especially in the biospace. Um, it can take decades.
Yep.
So what's yeah, how did you manage to move so quickly?
We do things in parallel. We take educated guesses. We take extraordinary risk all the time. We're very high risk, risk tolerant, I suppose, and failure tolerant. But we like to fail small and win big, right? If that makes sense. So we try and create a trial pipeline and a product development pipeline that is amenable to that. And so far, it's been working really well. Um, and yeah, that's the plan to continue that this year. We have enough trials in process right now to get the winning bolus, and then we have enough trials lined up for the half two of this year to really prove it out over the full 6 months in larger cohorts of animals to then have a wider rollout next year. So yeah, we just hedge bets a little bit and do things in parallel.
And in terms of the livestock producers, the farmers, ranchers, etc., that you've been speaking to, what's kind of their take on what you're doing and your approach and your products?
Um, they really love it. They love what we're building. I'm yet to meet a grazier that doesn't want a 5 to 15% feed conversion ratio improvement. That's really profound. There's going to be a good return on investment if we can make that happen for them. And there's side benefits that we've noticed as well. We think the product is likely to prevent bloat. We can't conclusively say that at the moment. We need a few more tests, but early signs are that it does. And that's huge as well. Like there's nothing in Australia at the moment that can do that. There was a bolus on the market that had to be withdrawn for safety reasons in the past, and it was much loved. So that the reception we're getting and lining up these trials and talking to producers and getting their feedback has just been like really uplifting. Like it's clear to me that if we can make this at scale, it will be adopted. And I haven't even talked about methane there. That's the other part. In supply chains where there's beef or wool or lamb or milk, um, enteric emissions are usually a very large proportion of the total footprint. And to be able to access the grazing market, which is so difficult to deliver a product to, is getting us some cut through there as well. So that's been amazing.
In the past, and this is more Australia because I know more about the Australian side of things on this than elsewhere, are the processors, the beef processors and sheep processors have had a significant pushback against boluses because
Hmm.
it's a piece of plastic that they have to fish out of the rumen and they don't want,
Yep.
plastic getting into the sausages, so to
Yep.
speak. How are you, addressing, obviously you're aware of that because you're nodding when I'm saying it. Are you actively speaking to the processors and trying to work through that with them, or how do you see, I guess, these additional risks? It's not the efficacy of the product, but it's a further downstream risk where someone else can jump in and make things difficult.
Yeah. Yep. So our bolus leaves no trace in the animal. It fully erodes into nothing, and there's nothing left in the carcass at the abattoir. No risk of anything going into food or posing risks on the factory floor. So it's not a plastic capsule bolus. It's called a tip erosion bolus, where
Mhm.
yeah, everything kind of you can think of it like burning down like a candle, and there's nothing left. So we chose to do that because before we embark on expensive R&D, we do talk to people and ask what they want, and how should this look as a product? And it was exactly as you say. Every processor we ever spoke to, as soon as you say the word bolus, I could see them getting angry and getting ready to tell me to go away. And that was because they've had these horror incidents with the plastic in the mints, or people injuring themselves in the processing plant. So that was loud and clear, and we took that on board and made sure that we don't have that issue. Um, and yeah, that's general process. I've been to a few abattoirs and seen everything that you can see in there and understand why that's important to them and designed accordingly.
You mentioned the 10 to 15% increase improvement in feed efficiency. Um, Is that all, if you can share that, is that all from just the methane, or what else can you share about with us about how you're impacting that fermentation environment?
Yeah, we're doing a lot of work on that from a like a microbiome standpoint. We do have an unusually robust effect. Like we've every time that methane's gone down, productivity, at least numerically, has gone up. And in a couple of cases significantly in the trials we've done. And it's unusual because that's happened at all different levels of methane abatement, different diets, different species. It's really honestly a bit weird. It's not what we saw in our development funnel when we were working with different inhibitors. So, that's why we chose the thing that we are working on because it does seem to have an unusually robust productivity effect. So I think I do suspect there's probably something else useful happening in the microbiome other than just inhibiting the growth of methanogens. But we don't really know at this point. We're working that out. It definitely does inhibit methanogens. We've caught it binding to important enzymes and important pathways in methanogens.
Because, if you look at the biochemistry of this, there's, a very long cascading sequence of reactions that lead to this buildup of hydrogen in the
Hmm.
rumen.
Hmm.
And at the end of the day, the methanogens are just these opportunistic microbes that grab that hydrogen because it's there and then convert it into methane.
Yep.
Um, and in some ways, it's the whole cascade of reactions that's what produces the energy and everything and the metabolites for the cow. And, you know, one way to think about it is that if you're just blocking the methanogens, it's a bit like the Dutch boy with his finger in the dike. You're trying to stop it breaking,
Hmm.
but you're not actually looking at that whole upstream process. Have you been exploring that upstream process and ways to impact that as well so that there's not the
Yep.
hydrogen there? And
We
what can you
have. Yeah. Exactly. So you've hit the nail on the head. Hydrogen in the absence of methane is the crux of this problem space. Like that's how you get productivity to happen. So hydrogen's a double-edged sword. Have it at the right level, and you drive volatile fatty acid formation in the rumen, which is what cows grow off, right? That's VFAs to a cow are like sugars to a human. That's what how they grow. That's what you want. So in the absence of methane emissions, hydrogen does accumulate because the other microbes that use hydrogen are less efficient at using it than the methanogens were. So at the right level, you drive productivity. Get hydrogen too high, and it's like a spanner in the works. You feedback inhibit all the metabolic reactions of the microbes that are degrading cellulose and starch and protein in the feed, and that's when you get issues. So that's essentially what we saw in a particular trial we did on a very high grain diet, because the fermentation rate is so much higher that when you inhibit methane emissions, you do get excessive buildup of hydrogen. So we've actually been able to solve that with co-additives that promote the growth of other microbial groups that do consume hydrogen and direct it towards VFAs so that you can still inhibit methane emissions on an already really efficient rumen that is building up hydrogen excessively. On pasture and on grass, we don't see that. Hydrogen typically seems to get to the sweet spot and drive productivity, and that's probably why why we're focusing on the bolus, because that just happens normally.
And going back to your PhD, which is synthetic bio, where where do you see or do you see opportunities to use, gene editing or those sort of things within the rumen to sort of further enhance, or are there other kind of novel and emerging technologies that you think will have significant impact going forward?
Yeah, in general, yes, I think there's room for a lot of technologies in this space. Like I can see in the future a vaccine being stacked with a bolus, and then later on that animal goes and gets another vaccine, and it goes on a feedlot and gets a feed additive as a powder. So there'll be different things that come in at different points of its lifetime, and different things that can go together. In terms of synthetic biology specifically, I think, gene editing the microbiome is a wonderful academic idea that will take time to bear fruit, and it won't work on the timelines of a startup and venture capital, in my opinion. Other approaches that rely on biology, you need the complexity to work with you because the cost of goods is higher whenever you work with biology. So if if you don't need the complexity of biology, then you shouldn't use it as your technology. Or if that complexity doesn't give you an edge, then you shouldn't use it. That's kind of the journey we went through at Number 8 Bio, right? We're trying to make a one carbon small molecule called compound called bromoform that you can make for like 3 cents chemically. Like why would you do that in an organism? It doesn't make any sense.
Mm.
So that yeah, biology has its place, right? But you gotta be wise to where it works and where it doesn't.
That's a really fascinating point because obviously the reason you wouldn't use the bromoform made out of the factory is because of the regulatory process, and if you can make it in a yeast, you you may be able to bypass the regulatory process or make the regulatory process easier. But it is very much, choosing a tool that's fit for the purpose that you want to use it and not having an overly complex tool and trying to get it to do something that there's a much simpler way to do.
Yep, yep, exactly. Yeah, it was a hard journey. I had to shun my former identity as a synthetic biologist and you know move into what we're doing now. That was fine. It was for the better.
And many of the feed additives, they have, the rumen adapts. So you use it in the first month or 2 months or whatever, and then after a number of months, the microbes adapt, and
Hmm.
the methane levels go back more to what they were. How are you managing that side of things?
Yeah, yeah. So we've done studies up to 4 months in duration now, and uh, yeah, there is like a change in the microbiome over that time, but and like a plateau. There's like a strong decrease at the start, and then it kind of levels off, but it doesn't go to zero in our case. So over that average 4 months, we've seen around 50% inhibition, which is still really good and like good productivity from that level of inhibition at the same time. So um, yeah, adaptation does happen. I think it will happen for a lot of technologies in this space, but it's not always a fatal problem, if that makes sense, depending on like the extent of it and the specific nature of it.
Mhm. And are there any particular tools that you would love to have that are either not yet available or only, partially available? The wish list.
Yeah, it's good. It's a really good question. I suppose in terms of mitigation technology, we're trying to work on that, but outside of that, there's definitely a need for more measurement technologies, and I know you've done a lot of good work in that space as well. It is expensive and difficult to quantify methane emissions. So there's heaps of innovation that can happen there. Um, Otherwise, I feel like you know carbon markets haven't matured as quickly as they should for this space to really thrive, and there's probably some innovation to be had there as well.
So we're almost up to time, mate. And is there anything else that you'd like to add, that we haven't already discussed?
Not really, no. Yeah, we're just gunning hard to make something that farmers love and are so eager to roll it out and tell the world about it and get the farmers to tell the world about it as well. So if anyone's listening that is interested in helping with that, feel free to reach out.
Cheers, Tom. Thank you so very much for joining me today.
Thanks for having me, Ash.
Thank you for listening to the Ash Cloud. Please subscribe to Ash Cloud if you've enjoyed this podcast, where I will continue to discuss food sustainability with guests who bring a deep understanding of the environmental, political, and cultural challenges facing our society and creative ideas on how to address them.